3 miles beneath the Pacific Ocean, in crushing darkness where the pressure could instantly kill a human being, lies the wreck of a Soviet nuclear submarine. For 6 years, it had been nothing more than a tomb on the ocean floor. But in 1974, the CIA decided to do something that had never been attempted in human history: steal an entire submarine from the bottom of the sea. They built a ship unlike anything the world had ever seen, a 619-foot engineering marvel with a hole straight through its heart and a mechanical claw that could reach into the abyss itself. This is the story of Project Azorian, March 8, 1968. A Soviet Golf II class ballistic missile submarine, designated K-129, disappeared somewhere in the North Pacific. 78 men and 3 nuclear missiles simply vanished into the ocean's depths. The Soviets searched for months, deploying dozens of ships and submarines. They found nothing, but the United States Navy had been listening. The U.S. had secretly deployed a network of underwater microphones across the Pacific, the Sound Surveillance System, or SOSUS. On March 11th, these sensors had recorded a massive underwater explosion 1,560 miles northwest of Hawaii. Triangulating the acoustic data, American intelligence pinpointed the wreck's location to within a few miles. The submarine lay 16,500 feet down, deeper than the Titanic, in an underwater mountain range that would later be named after the fallen sub. Inside that wreck were Soviet nuclear missiles, code books, communication equipment, and possibly most valuable of all, the submarine's nuclear reactor and guidance systems. It was an intelligence goldmine worth billions of dollars. But there was one problem. No technology existed that could lift a 2,000-ton object from 3 miles underwater. What the CIA was proposing was physically impossible with 1970s technology, so they decided to invent it. The project was so secret that it didn't officially exist. Codenamed Azorian, it required a cover story so elaborate it would fool the entire world. Enter Howard Hughes, billionaire, recluse, and the perfect frontman for an impossible mission. Hughes's company would build what appeared to be a deep-sea mining vessel designed to harvest manganese nodules from the ocean floor. The cover story was brilliant because it was based on real science. The deep ocean floor is indeed carpeted with metallic nodules rich in manganese, nickel, and other valuable minerals. A mining ship would need exactly the kind of heavy lift capability required to raise a submarine. Construction began in 1972 at a cost of over $800 million, equivalent to $5 billion today. The Hughes Glomar Explorer would be the most sophisticated ship ever built, incorporating engineering advances that pushed the boundaries of what was possible. But the ship's most radical feature was invisible from the outside: a moon pool, a massive opening in the hull, 199 feet long by 74 feet wide, that would allow objects to be lifted directly up through the bottom of the ship. The engineering challenges were staggering. How do you maintain a ship's structural integrity when you cut a hole the size of a city block through its center? How do you prevent the ocean from flooding in? And most importantly, how do you lift 2,000 tons from a depth where the water pressure exceeds 7,000 pounds per square inch? The answers would require innovations in hydraulics, metallurgy, and precision engineering that had never been attempted before. Every component had to be designed from scratch, tested to destruction, and rebuilt stronger. The heart of the operation was a hydraulic lifting system of unprecedented power. 4 massive hydraulic cylinders, each 60 inches in diameter with a 15-foot stroke, capable of lifting 7,000 tons, more than the weight of the Eiffel Tower. But raw lifting power was just the beginning. The real challenge was precision control in a chaotic environment. A ship at sea is constantly moving, rolling, pitching, and heaving with every wave. Any one of these motions could snap the lift cables or destroy the submarine being raised. The solution was a gimbal platform, a sophisticated mechanical brain that would isolate the lift system from the ship's movement. The platform can accommodate up to 8.5 degrees of roll, 5 degrees of pitch, and 15 feet of vertical heave, ensuring the lift remains perfectly stable, even in rough seas. The gimbal system required bearings unlike anything ever made, 48-inch diameter assemblies capable of supporting 5,000 tons each. The bearings used 3 races with continuously rotating middle sections to prevent the rollers from ever-changing direction as the ship moved. Below the gimbal platform, the ship would deploy a tapered pipe string, miles of specially manufactured steel pipe, each 30-foot section joined with tool joints torqued to withstand forces that could snap a house in half. At the bottom of this pipe string hung the most sophisticated piece of equipment ever lowered to the ocean floor, a mechanical claw the engineers nicknamed Clementine, 8 hydraulically operated arms, each capable of independent movement, controlled by seawater hydraulics and guided by sonar and cameras. Clementine was a robot submarine, equipped with 8 propeller thrusters for precise positioning and sophisticated acoustic systems that could operate independently of the ship 3 miles above. It could maneuver to within inches of its target, regardless of what the mothership was doing. But would it work? There was only one way to find out. July 4th, 1974. The Hughes Glomar Explorer departed Long Beach, California, under the cover of a mining expedition. Publicly, she was heading to the Pacific to test revolutionary deep-sea mining technology. In reality, she was carrying the most sophisticated espionage equipment ever deployed. The ship's dynamic positioning system used computer-controlled thrusters to hold her position within inches over a single point on the ocean floor, a feat of engineering that wouldn't become routine for another decade. For days, the crew lowered pipe section after pipe section, building a steel column that stretched deeper than Mount Everest is tall. Each joint had to be perfect. A single failure would mean losing the entire string and ending the mission. July 31st, 4 a.m. After descending for 3 miles through crushing darkness, Clementine's landing legs finally touched the Pacific floor. Sonar painted a ghostly picture of the target, the broken hull of K-129, partially buried in sediment that hadn't been disturbed since the ship sank 6 years earlier. What happened next required a precision that defied belief. Clementine had to position herself over the submarine's hull, extend her 8 mechanical arms, and embrace a 2,000-ton object without disturbing its structural integrity. The slightest miscalculation could cause the wreck to break apart, scattering secrets and debris across the ocean floor. For hours, Clementine's arms probed the wreck, feeling their way around twisted metal and torn hull plates. Finally, at 9:13 a.m., the claw closed around its target. For the first time in 6 years, K-129 began to rise from the dead. The ascent would take 3 days. 3 days to lift a secret from the deepest part of the ocean. 3 days for the most audacious engineering feat in human history to either succeed spectacularly or fail catastrophically. The psychological pressure on the crew was immense. They were attempting something that had never been done before, using technology that existed at the absolute limits of human capability. And they were doing it while being watched by Soviet spy ships. A Soviet naval tug had been following the Explorer since she entered international waters, photographing everything, trying to determine what the strange American ship was really doing. The crew had to maintain their mining cover story while conducting the most sensitive espionage operation of the Cold War. Psychologists who later studied the mission noted the extreme stress reactions among crew members. Men who had worked on offshore oil rigs for decades reported feeling levels of anxiety they'd never experienced. The knowledge that they were literally making history, combined with the constant threat of discovery, pushed many to their psychological limits. But the greatest psychological pressure may have been on the engineers themselves. They were betting their reputations, their careers, and possibly their lives on calculations and theories that had never been tested at this scale. Every decision carried the weight of potential catastrophe. The ship's medical officer noted unprecedented levels of stress-related illness during the operation. Seasoned sailors were experiencing symptoms of severe anxiety. Some crew members reported nightmares about the deep ocean, about mechanical failures, about secrets slipping back into the darkness forever. August the 5th, 12:55 a.m. With the submarine only 2/3 of the way to the surface, disaster struck. 2/3 of K-129 broke away and plummeted back into the abyss. In an instant, the most expensive espionage operation in history became a partial failure. The nuclear missiles, the reactor compartment, the most valuable intelligence, all of it was gone, scattered across 3 miles of ocean floor. What remained in Clementine's grasp was the forward section of the submarine, about 38 feet of hull containing the crew quarters, some electronics, and the bodies of 6 Soviet sailors who had died when their submarine sank. In one of the most remarkable moments of Cold War humanity, the CIA crew conducted a military burial at sea for the Soviet sailors. The ceremony was filmed and the footage was later returned to Russia as a gesture of respect between enemies. But questions remain about what was actually recovered. Declassified documents suggest the CIA may have obtained more intelligence than they publicly admitted. Some theories propose that the break was staged, that the valuable parts of the submarine were secretly recovered. When the story finally broke in 1975, it sparked massive controversy. Congress investigated whether the enormous cost was justified by the limited intelligence gained. Critics argued that the mission was an expensive failure that accomplished little beyond demonstrating American technological capabilities. But the engineering legacy of the Glomar Explorer lives on. The innovations developed for Project Azorian revolutionized deep-sea operations. Today's offshore oil industry uses direct descendants of the ship's dynamic positioning systems, heavy lift technology, and precision underwater robotics. The Glomar Explorer herself was eventually converted into a legitimate deep-sea drilling vessel, her moon pool and lifting systems repurposed for commercial operations. She operated until 2015, when she was finally scrapped, taking her secrets to the grave. But somewhere in the deepest Pacific, the remains of K-129 still lie scattered across the ocean floor. The nuclear missiles that started this whole operation remain entombed in crushing darkness, their secrets lost forever to the deep. The Hughes Glomar Explorer proved that, with enough money, enough genius, and enough determination, humans can reach into the deepest places on Earth and touch the impossible. But some secrets, once lost to the ocean, may be meant to stay there forever.